Hi, Assalamualaikum and a very good morning. My name is FATIN AISYAH BINTI HUSSIN and my metric number is CA20130. In today's video, we're gonna talk about quality of service. So, what else can we be covered in this quality of service? So, first of all, we're gonna talk about the introduction. Like, not everyone knows about quality of service, right? So next, we're gonna talk about congestion management tool, and then we're gonna talk about QoS identification and marking, and most importantly, we're gonna do some recap and reference that I do to achieve this video. So without further ado, let's go to the introduction. Quality of service, or QoS, refers to the capability of a network to provide better service to selected network traffic over various technology, including frame relay, asynchronous transfer mode, Ethernet, and SONET and IP router network that may use any or all of these underlying technologies. For the benefits of QoS, the first one is control over resources. You have control over which resources, which is bandwidth, equipment, wide area facilities, and so on, are being used. Next one is more efficient use of network resources. Using Cisco's network analysis management and accounting tools, you will know what your network is being used for and that you are servicing the most important traffic to your business. Next one is tailored services. The control and visibility provided by QoS enables internet service providers to offer carefully tailored grids of service differentiation to their customers. Coexistence of mission-critical applications. Cisco QoS technology makes certain that your one is used efficiently by mission-critical applications that are most important to your business, that bandwidth and minimum delays required by time-sensitive multimedia and voice applications are available, and that other applications using the link get their fair service without interfering with mission-critical traffic. Foundation for a fully integrated network in the future. Implementing Cisco QoS technology in your network is a good first step toward the fully integrated multimedia network needed in the near future. So now that we know the benefits of QoS, let's go to the QoS identification and marking. So the first one we're gonna hit is the congestion management. Because of the bursty nature of voice, video, data traffic, sometimes the amount of traffic exceeds the speed of a link. At this point, what will the router do? Will it buffer the traffic in a single queue and let the first packet in be the first packet out? Or will it put packets into different queues and service certain queues more often? Which one? Congestion management tool address this question. Tools include priority queuing, custom queuing, weighted fair queuing, and class-based factored-ware queuing that we're gonna discuss more in the next one. Next one, we're gonna talk about the queue management. Because queues are not of infinite size, they can fill and overflow. When a queue is full, any additional packets cannot get into the queue and will be dropped. This is what we call a tail drop. The issues with tail drop is that the router cannot prevent this packet from being dropped even if it is a high priority packet. So, a mechanism is necessary to do two things, which is one, try to make sure that the queue does not fill up so that there is a room for high priority packets. And second is allow some sort of criteria for dropping packets that are of lower priority before dropping higher priority packets. Now let's talk about link efficiency. Many times, low-speed links present an issue for smaller packets. For example, the serialization delay of a 1500 byte packet on a 56 kilobyte per second link is 250 milliseconds. If a voice packet were to get behind this big packet, the delay budget for voice will be exceeded even the packet left the router. Link fragmentation and interleave allow this large packet to be segmented into smaller packets interleaving the voice packet. Interleaving is as important as the fragmentation. There is no reason to fragment the packet and have the voice packet go behind all the fragmented packets. So now we're gonna talk about the congestion management tool. First of all is FIFO or FIFO, Basic Store and Forward Capability. In its simplest form, FIFO queuing involves storing packets when the network is congested and forwarding them in order of arrival when the network is no longer congested. FIFO is the default queuing algorithm in some instances, thus requiring no configuration, but it has several shortcomings. Most importantly, FIFO queuing makes no decision about packet priority. The order of arrival determines bandwidth, promptness, and buffer allocation, nor does it provide protection against ill-behaved application, and bursty sources can cause a long delay in delivering time-sensitive application traffic and potentially to network control and signaling messages. FIFO queuing was a necessary first step in controlling network traffic, but today's intelligent networks need more sophisticated algorithms. In addition, a full queue causes tail drops. This is undesirable because the packet drop could have been a high priority packet. The router couldn't prevent this packet from being dropped because there was no room in the queue for it, in addition to the fact that FIFO cannot tell a high priority packet from a low priority packet. Next is PQ, which is prioritizing traffic. PQ ensures that important traffic gets the fastest handling at each point where it is used. It was designed to give strict priority to important traffic. Priority queuing can flexibly prioritize according to network protocol, for example IP, IPX, or Apple Talk. Incoming interface, packet size, source destination address, and so on. In PQ, each packet is placed in one of 4 queues, high, medium, normal, or low, based on an assigned priority. Next, CQ, which is granting bandwidth. CQ was designed to allow various applications or organizations to share the network amongst applications, with specific minimum bandwidth or latency requirements. In these environments, bandwidth must be shared proportionally between applications and users. You can use the Cisco CQ feature to provide guaranteed bandwidth at a potential congestion point, ensuring the specified traffic a fixed portion of available bandwidth and leaving the remaining bandwidth to other traffic. Class-based WFQ. Ensuring network bandwidth. Class-based WFQ or CBWFQ is one of Cisco's newest congestion management tools for providing greater flexibility. When you want to provide a minimum amount of bandwidth, use CBWFQ. This is in comparison to a desire to provide a maximum amount of bandwidth. Core and traffic shaping are used in that case. CBWFQ allows a network administrator to create minimum guaranteed bandwidth classes. Instead of providing a queue for each individual flow, a class is defined that consists of one or more flows. And that's all for this topic. But first, let's do some recall. So, quality of service is the use of mechanisms or technologies that work on a network to control traffic and ensure the performance of critical applications with limited network capacity. It enables organizations to adjust their overall network traffic by prioritizing specific high-performance applications. And this what is QoS is about. So now let's talk about 5 management tools that are important in QoS. Here are 5 management tools that are important, which is first one is FIFO or FIFO, PQ, CQ, WFQ, and CBWFQ. So easy to memorize, right? So this 5 management tool helps to prevent any difficulties or any delays in networks. In a continued evolution toward end-to-end services, Cisco is expanding QoS interworking to operate more seamlessly across heterogeneous link layer technologies and working closely with host platform partners to ensure interoperation between networks and end systems. QoS is one of the forefront of networking technology. The future brings us the notion of user-based QoS, in which QoS policies are based on a user as well as application. Capabilities such as NPAR and its ability to read deeper into packet provides a robust implementation for identifying flows. Cisco end-to-end QoS solution from desktop to desktop make a Cisco network the premier provider of end-to-end quality service. So I think that's all from my explanation today. Hope you enjoyed the video and have some understanding and more knowledge about QoS. So that's all from me. Love and peace. Thank you very much.